So we are going to see the problem of contiguous array. So this problem tells that given a so this problem tells that given a binary array of nums, array called nums, return the maximum length of a contiguous subarray with an equal number of n, 0 and 1. That is, so so we will have an array containing only 0 and 1, but we have to find a subarray, a largest subarray that has equal number of zeros and ones. So uh, this is first of all prefix sum. Mm, by algorithm itself, I saw this is a prefix sum. So one second, I have moved to some other. Continue. Okay, so um, so I think in prefix sum, what we will do in prefix sum, in prefix sum, we will check the total sum at the jth position, and then we want the array to have some we want the array to follow some condition, and with that condition what we will do is that what is there any subarray that is starting from the first to here, that is present, that ends at where this subarray starts, which satisfies the condition of this subarray. So that is the uh, like if I want to tell it in a easier manner means prefix sum is like you are looping through the array, and let's say you are at a jth position, and the array from 0 to j is, let's say, the j subarray, and we want to find, is there any subarray that is starting somewhere and then ending at j? Okay, that's what we want to find because we are at j. Okay, and this, so we know that the ending position we are finding is a J for the subarray, for the required subarray. And we want to know the starting position. So we are searching that is there any subarray that has ending position at J and any starting position. So if we find a suitable starting position, a valid starting position that satisfies the condition that they have given in the problem, then we find out the array, because we already told that the end position should be J, and we will change that. We will look through the whole array, so we will check everything. But in this particular end position, that is J, we want to find is there any array present where we can have the starting position. So for that, we are we are finding some subarray, that is another subarray that is starting from zeroth position to some other intermediate position, and our required subarray should start from the ending of the this array subarray and then J. So our required subarray will start from the ending of that array and till J. So we want to find which subarray ending will be the start of our required subarray, given that the condition of the subarray is this. So uh, that is the prefix summed up. Okay. In this problem, what we have to do? Obviously, in most of the prefix sum problem, we will use hash map. Okay. So uh, so I think prefix sum in this kind of an array that contains only 0 and 1 will have all the number of ones, like for each position, for each index in the array, you will have a prefix sum that contains a sum of all previous elements. So since 0 doesn't contribute to the sum, so any prefix sum of a particular index will give the number of ones before that index. So that is one idea. So oh shit, I forgot to start the timer. Okay, we will start from now. Uh, okay, so okay, first we have to find what are we storing in the key and value of the hash table. That is the core. I find out that that is where each problem method varies. So I think first of all we have to store 0, 0 in the hash table. Um, Now if we didn't store 0, 0 in the hash table, then while comparing the first element, uh, like if some result comes to 0, then we cannot find anything in that hash map. So we are putting 0 as default. Okay. Uh, so Okay. We move to first element. Let's say this is an example array 0, 1, 1, 0, 1. That is the example array we are taking. And we will, let's say I am looping through the first element. So there, uh, I think I need to keep 0 and their frequency, 1 and its frequency. That's what I need to do, I think. Okay, so if I find 0, then I should update it the key by 1. If I find 1, I should update it the key by 1. So let's say in the array, we have here the prefix sum to be 0, prefix sum to be 1, 2, 2. Mhm. That won't help, I guess. I think we have to do the prefix sum with index. That, uh, let's think. Okay. So what I am thinking is that the prefix sum gives the number of 1. So if the prefix sum gives number of 1, so if at index I the prefix sum is n, so we can see that for index I we have I plus 1 element of the array. At the index I you have covered I plus 1 element, and if the prefix sum is n, then you have n number of ones present. So to find the number of zeros, what we will do? We will subtract it with the total element. So total element is I plus 1 minus n. You will, wait, minus prefix sum. You will get number of zeros. So if we want the number of zeros to be equal to the number of, So the number of so uh, so we want the zeros and ones to be equal. So for that, if number of zeros should be equal to number of prefix, then what should be the condition? Two prefix. Okay. So we got the condition that I plus 1 by 2 should be equal to the prefix sum. So what does that mean? If we are searching at a particular index, if that index plus 1 divided by 2 is equal to the prefix sum of that index, then it is a valid uh, array that we want. Okay, let me check here once. Index is 0, 1, 4, so okay. So that what formula is correct till now. What I have done, maybe I can. Okay, okay. This formula is working. That is I plus 1 by 2 is equal to prefix. So now what I'm thinking is we have to store the index plus 1. Wait 1 second. So okay, let's make, to avoid confusion, we will take the 0 to be minus. Wait, I don't think we need 0, 0 here. Hmm, do we really need 0, 0? Okay, let's start from the first element and we will see why we need 0, 0. I mean, the initial 0, 0 that we will give for the thing. Okay, so now, so, okay. So let's say we are storing, um, first in sum, we are storing what? This prefix sum. First is 1. Now, uh, first its value was 0 and now it's 1. They're putting it there. Prefix sum is 1 at 0 index. And then we are checking. Index is 0 right now. At 0, I is equal to 0. I 0 plus 1 by 2, 1 by 2. equal to prefix. Is there any prefix sum of 1 by 2? No. So we will go. The whole point of having prefix sum is hash map, I think. Because if we don't have hash map and we have to find if some element is present in an array or not, we have to loop through the whole array. So just because hash map is existing, that's why we are using prefix sum. Otherwise, I don't think it has any advantage over any other method. Okay, and then we are going to the second element and it's still sum is 1. So we are checking if 1 plus 1, 2, 2 by 1, 2 by 2, 1, exist or not exist. So that means we have an array, okay, and we will have count is equal to we will increment the count. Okay, now count will be 1 and we will have max count also. And then we are going to the next and then we are adding it. So 1 1 and then we are going to the next element. So sum will be become 2 and we are checking index is also 2. So 2 plus 1 is equal to 3, 3 by 2. There is nothing like 3 by 2 there. So we will again add this 2 2 and then we will increase the sum to 2. I am doing it for the array of 10101. Okay, 2 and then 2 plus 1 is equal to 3, 3 by 2. Again, wait, 1 second. Wait. Now our sum is 2 only. Yeah. Sum is 2. Sorry, our sum is 2. Yeah. Okay, index is 3. So 3 plus 1 is equal to 4. 4 by 2 is equal to 2. So we have 2 here. So we will make count to 2. If count is greater than or equal to this I plus 1 by 2, then we will increment the count. Okay, then we will have the max count. Okay. And now we will do 2, 3. And then we will go to the next element. And we have 3 here. And index is equal to 4. 4 plus 1 by 2 still 5 by 2. So 5 by 2, there is nothing here. So we will skip. So we will have 3, 4. Okay. Now our last count value will be the maximum length of contiguous array. Okay, now let's try to code it. Okay. So Now we will first make a hash map of integers. Wait, hash map of integer hm is equal to new hash map, and then I don't think we need to give the first value of the hash map. So um, now int prefix sum is equal to 0. Int count is equal to 0. And then what we will use for int I is equal to 0, I is less than nums dot uh, now on the first iteration we will first increase the sum. So prefix sum is equal to nums I. After increasing the sum, what you will do? Uh, you will compare. If hm dot con contains key I, I plus 1 divided by 2. So if there is a prefix sum like this or not, if it exists, then we have to uh, make the if it exists. Uh, so wait, at a point, at a particular index as the end of the subarray, you may have more than one subarray that have equal number of one. So how we will find the largest one? So to find the last, if we have 10101 as an array, and at this point, 1, 1, 2, 2, 3. At this point, you have this one and also this one that has equal number of 1 and zeros. So, what will our hash map looks like? 1, 0, 1, 1, 2, 3, 2, 2, 2, 3, 3, 4. So this is how our hash map looks like. So if we are at 1, 2, 3, here, here, and I 0, 1, 2, 3. 3 plus 1 by 2 means 2, 4 by 2. So 2 is present here or not? 2 is present. If it is present, if it is present, then if it is present, what we will do? We will take the index of that. But wait, um, both can have, wait, this is the longest array. But this method that I have told will find the smallest subarray or the first subarray that it finds. It will not find the largest. Uh, wait, here the index is 3. Okay, so we have 4 elements here and only 2 ones, which means this full thing is valid. So if that case satisfies, then it means the whole array is, if this condition I plus 1 by 2 is equal to plus 6 is true, then this then the subarray will start from 0 to 8. Okay. Okay, then let's come to this position. 1, 2, 3. Now here Now here we are at here. Okay. So we are seeing that uh, okay, here we are seeing that here we will check index is equal to 3, 4, 5. Index is equal to 5. 5 plus 1, 6. 6 by 2, 3. Do we have anything like 3 here? No. That's because we don't have anything from the starting. But still, what we can do is we have 5 as our index. Okay. And then we have wait, it should have shown like the index is 5. So the total element is 6. The number of 1 is 3. So which means, wait, the number of, this is a valid thing. But what if we have 1 here? Then what will happen? So let's say we are going like this. So at index is equal to 0, you have 0. Wait. At index is equal to 0, you have 0. 0, 0, 1, 1, 1, 2. Okay. Now we are comparing the last element. Okay. So I, the 5, 6 by 2, 3. But here the sum is 2. So what we will do? Should we really store the prefix sum and the thing? Um, Now, So what is the condition? From 2 to 5 you should have. So here the prefix sum is 2. So what condition it should satisfy? Here till the prefix sum is, wait, till here the prefix sum is 2. And till here the prefix sum is 0. And from here to here, what can we do is, we can find the subarrays in the hash map, prefix sums in the hash map. Wait. This prefix sum, prefix. Okay, wait, this should be equal to even. So previous prefix, wait, I sum till I, my sum till j minus sum till I should be even. So if that is even, then so this is our condition. That is sum of the first element to the current index that we are in, prefix sum till j, and then we need to find any other element that has prefix sum, which we subtract it from this, and we should get it as even. So what do I do then? If I subtract 5 from here, but 1 second, hash map will not store this much. 14131. It will only store 1 4. So how? It will also store 0 1. So hash map will replace if the keys are same, right? So I think then I have to store the index in the key. So 0 1 2 3 4. Now I have to find 5 minus shift. Wait. This is at fifth index and this is at second index. Okay. And now there. So inside we have four boxes, and we need to exactly have half of that once. So the difference between these two, that is the difference of the prefix sum, ref j minus ref I should be equal to half of the difference of the index. And particularly, I have to increment it. So j minus I plus 1. So you have, if I have to find it, but for this I need the index also. So how can I avoid the index? Uh, should I really store the index? Yeah, the index is correct. The really hard part of prefix sum is to find the condition, how to implement the condition, and how to come up with what that hash map should contain. That is the only part. Otherwise, the prefix sum part is same for everything. Um, Let me think. So I know this logic is correct, but how should I exactly correlate them and implement? That is the problem. Uh, or should I store some other thing in the hash map? Wait, we know J, we know prefix of J because that's where we are at. But the problem is there are two different variables. So if there are two, how can we check them? The thing is, the index should be, the prefix sum should be half of the index difference. Uh, Uh, Perfect sum. Okay, let me eat a biscuit. So now the prefix sum should be Then for a single prefix sum, can there exist? Mhm. So for a given prefix sum, for the given value in the hash map, if we use this equation, prefix sum j minus prefix sum I divided by 2 is equal to j minus I plus n. That formula for a given prefix sum I, the index of the I is constant. So what we can do is, uh, but not everything will satisfy this equation. So uh, why all the prefix sums questions are difficult? So I found out the formula. Okay, I think it's time to see the solution. Okay, let's see YouTube. Contiguous array. Shit. So